Hello, welcome to session number 6 in the series System Design. My name is Anurag Nigam, and in this series, I'm talking about system view for system simulation. And in this session, I'm going to revise some of the concepts and fill in some of the gaps before I proceed to something bigger. Okay, so I'm going to stress a little bit on analog modulation. So I'll give a example of a FM receiver, and we will see modulation, FM modulation in system view. Now this is very simple. This is very preliminary, but I felt it is important that you are aware of number of things which we are going to use later. So what you're going to do is I have just opened a blank workspace, and I'm going to just save it, and I'm going to call this as FM mod. So I'm going to do FM modulation here, right? So we can rename the designs, and let me call this one as FM modulation and say OK. And here I'm going to change the name of the analysis also. So I'm going to rename this as FM analysis, right? Okay, so now we are all set. Now in analysis, I'm going to go ahead and refer to the right design. And let me see if I'm recording. Yeah, I refer to the right design, and then I put the sampling rate to be 2 megahertz, right? And this is frequency resolution of 1 kilohertz. So that's good. So now as earlier, I will just put a sine wave source. So I can say sine, and here is the sine wave. And this is by default, 5 kilohertz. So I'm not going to touch this one. Okay, next thing is I am going to put an adder. So as I can add some noise to this. So I will put an adder here as we have done earlier in session 1. So I'll be able to put some Gaussian noise. So to put the noise, I can choose Gaussian, and I have to specify in this standard deviation. So that's my noise here, and here I am going to put a standard deviation as 0.05 volts, right? And just connect it. Now I will put a tune on standard deviation. So I can put a tune on standard deviation, and then I will add a slider for this. Okay, so I will just go ahead and put a slider here. Double click that, add standard deviation to it, and I'm going to suppress the prefix, and I'm going to go from anywhere from 0.01 to, let's say, 0.3, and I'm going to have 10 ticks, and I think that's it. Okay, so that's my standard deviation here. And also I'm going to put on this one auto recalculation, right? So this is done, and I don't have a sync here, so let's see what's the complaint about. He TSDF, there are no models that control the simulation, no data collection. Okay, is needed. Okay, so here let me put some information, some sync, right? So let's put a sync here, right? So that's the sync, and let's put a spectrum analyzer if you want to see spectrum analyzer, and that's it. So here let me call this as, give it a name, call this as input signal, right, and I will call this one as input spectrum, right? Okay, so done that. Then I'm gonna just connect this, and let's see, still complaints. It doesn't complain, right? So we have done this much earlier, and you can add a graph. Let's say graph, and under general, you have got input signal in time, and here I can say is time domain 1, and here I would say input sine wave, and I'll be okay with it. So that's the input sine wave with a noise on it, right? And then you can also put here another graph, and under spectrum, sorry, under spectrum you can put the spectrum power, right? And here I'm going to say spectrum 1 and input spectrum, and hit OK. So that's your input spectrum. You are at 5 kilohertz, right? So remaining is the noise. Okay, so that's done. Now let's see how can I modulate this. The input can be used to modulate a frequency. So let's keep this one up somewhere here. Okay, so I can pick up a modulator, right? Uh, if you want, you can put some form of a filter, but I'm just going to have a modulator here. And this modulator can be used, this can be used as, three options here. So you see these inputs: Q, phase, frequency, I, and amplitude, right? So if you want to use this as an analog modulation, right, then one of the terminals is going to be a constant 1, because that's what it is going to multiply with. So I have to put here a constant, look for a constant, and that constant value I'll put as 1. So basically that's that. And again, there is a cosine and a sine. So there is one quad out, and then there is one out. So I'm going to use one of them, which is out. But before that, I have to set this up. So I'll set this up as amplitude to frequency modulation. And I can put here a carrier, which basically I can generate later on. So how about we just do this, right? So because we have the information, so we can do right click and say add tab. And what I'm going to do is add some parameters, and also I'm going to add equations, right? So in the parameters, I'm going to add a parameter called channel. Okay, so it starts with capital C. This is a channel from 1 to 100. So let's say from 1 to 100, and let's say default value is 50, and it's a unitless, but it's tunable, and it's a positive integer. Okay, so we have a channel defined here. Then that's going to be available in the design variable, right? So next is I'm going to write some equations, and I would say I want this channel from 88 megahertz to 108 megahertz as a FM receiver is, right? Or FM transmitter is, right? So 88 to 108, we are going to look at 150 kilohertz channels, right? And basically they are going to be separated out by 200 kilohertz. So if I start at 88, the first channel will be 88.1, right? So let's say if you have a channel spacing, okay, so let's say that's going to be 200 kilohertz, right? And then you would say f min. So f min in this case, let me see how can I increase the text size. Let's go to properties and equations. It says Courier 9. Let's put 14 onto it and say okay. So now you can see. Okay, carrier spacing is 200 kilohertz. F min is going to be 88 E6 plus spacing by 2. Channel spacing divided by 2. So that's going to be 88.1, and F max is going to be 108 E6. Okay, so first I'll generate all the channels. So I will call this as F data. That would be a matrix which will start at F min, and then you have to specify the step size, which will be channel spacing, right? Channel spacing, and that will be F max and square bracket close. Let's see if this does that. So I'll right click this and say run equations, and let's see if there is an error here. Equation 2. Oh, spacing. Correct. And run equations. So here, what you will see is F min is 88.1 and F max is 108 megahertz. So 88.1, 88.3, 88.5. Let's see if I can adjust its font also. Probably not straightforward, but that's what it is. And then I would say, so this is a matrix which has 100 channels. So FC is equal to F data. So this is an array, and in F data I am going to pick up a certain channel, which is going to be this. So I guess this should work. So if I run these equations, so I have FC as 97.9 megahertz, right? Okay, so that F channel is generated. So I'm going to put that F channel into the modulator. So I'll go to the modulator, and here I can put here as FC. So F channel is done, and then you have to specify whether this modulator is used as a frequency modulation or so basically here you have to set amplitude to frequency, and so that means that this is a frequency modulation. Now the amplitude of the input signal is plus minus 1, right? So that's fine, but then you have to specify the modulation depth. So how many kilohertz per volt kind of thing. So if I put here 75 E3, so that many kilohertz per volt. So if I go plus 1, it will give me 75 kilohertz, and if I go minus 1, it is going to give me minus 75. So if the center is 88.1, you can plus 75 kilohertz and minus 75 kilohertz. So basically you have 150 kilohertz of bandwidth, and then the guard band between the two channels is going to be uh, 50 kilohertz, right? So 25 from this channel, 25 from that channel. So basically 50 kilohertz is the guard band. Okay, so if you don't understand that, I'll just draw it out. Okay, so forget about this. So let me draw that. So what I'm talking about is you have, sorry. Okay, so you have got 88.1 megahertz. So basically 100 kilohertz on the left is going to hit you 88 megahertz, and 100 kilohertz on the right is going to make you 89. It, and it is going to be centered at 88.3. Again, this channel would be plus minus 75, and 25 would be left here and 25 here. So the total guard band here is going to be 50 kilohertz. So that, like this, I will keep on going up to 108 megahertz, and there are going to be 100 channels here, right? So that's the scheme. That scheme is being defined here in equations, right? So if you look at these parameters, you will see the centers are at 88.1, 88.3, 88.5, and so on. And then the plus minus 75 is going to give you a bandwidth of 150 kilohertz, right? So that's there now. So that's that. So now let's say if you want to do something like phase modulation, so you will choose amplitude phase, and in that case you have to specify the phase sensitivity, per volts how much phase variation is there. So basically that's also a depth of modulation for phase modulation, but we are at frequency modulation, and we are saying 1 volt is going to be 75 kilohertz of deviation. Okay, so when I click OK, okay, so it says that the center frequency it has got as 97.9 kilohertz, and this will give you the output, right? So I can display the output here, right? I can display this output here. So I can go here and put here a sync, and it's good to see what it looks like in, because this is going to be a complex signal. Sync, and here I will call this as a output sync, output signal, right? And then I'll put a spectrum analyzer here, and okay, spelling mistake. Okay, spectrum. So you are going to get an envelope here, right? I'm sorry, not a complex number, but an envelope. Okay, so this one is there, and this one I will call this as out spectrum. Okay, so this will be the output spectrum, this will be the output signal, and just calculate this. Okay, so now I am going to go ahead and plot that. So I'll add a graph, and here I am going to plot a spectrum first, output spectrum in dBm, and I will call this as output spectrum, and this again I will call the title as output spectrum, right? Okay, so that's your output spectrum, right?
This one is your input spectrum. This is just a 5 kilohertz tone, which is modulating the frequency here. So basically, you are seeing your 150 kilohertz, but 97.9, 98.9. So that's 1 megahertz, and 96.9. That's another megahertz. So basically, that's your sampling rate 2 megahertz. So that's your 2 megahertz. Now I can tune the channel, right? So if I want, I can tune that channel. So I'm gonna just cancel that. Let's say if I put another tuner here, go to annotation bar and put a tuner here. What happened? Okay, let's do this again. Okay, so that's a tuner where I'm going to assign a channel. But before I do that, that channel has to be tunable, right? So go to equations. And the parameter, you see it's untuned, right? So here that would be available as a channel, and I will remove the subscript here or prefix, and I'll snap to integers, put here a 6 as 10, and that's it. So now I am sitting at 50, right? And I'm looking at a spectrum which is over here, right? So let me just do that. Now, okay. Now I can change the channels here, right? So if I change this channel, okay, I have to put this on minimize. Sorry. So right now it's at 61 channel, and the channel frequency is 100.1. And here is my spectrum at, so one of them is the previous one, which is the brown one, which is at 90, what was it, 50th channel. Let's get back to 50th channel. So that's the 50th channel. What? Oh, that's 51st channel. So that's the 50. Oh, too sensitive. Okay, so that's the 50th channel. Now you might say why it looks different. Okay, so let's first accept that. Then I can go here to analysis, and under options I see repeatable random sequence. Okay, okay. So I have repeatable random sequence. Let's change it. So we are at a different channel here. Let's get back to 50. So now you see the perfect match. Yeah, because noise is random, right? And every auto calculation is going to compute a different noise, right? So that's why unless you declare it as a repeatable from calculation to calculation, the noise numbers are going to differ, right? So that repeatable random sequence is going to do that, right? Because internally this Gaussian noise generator is a random sequence generator, right? And you are saying that every auto calculation keep that random signal to be same. Don't recalculate the random signal, right? So here now it overlaps. So now you understand we are sitting at, why it says no design. Okay, we are sitting as 97.9. Now if I change the channel to 60, or 66, we are sitting at 101.1 megahertz. Now, this is my uh, original signal, the brown one, and the red one is my new signal, tune signal. And if I want to accept the tune value, I have to click this. On the tune window, I have to click the green button. Right now, the problem is that the frequency is scaling. So I don't want to do the frequency rescaling, right? So what I'm going to do here is I'm going to insert a block here, which is going to keep this x-axis stable, right? Okay, so here, one more way, maybe, let's explore that. Let's make this as 88E9 to 90 to 108, 108E9. Okay. Oh, I went to gigahertz, sorry. 88E6 to 108E6. Fine. Oh, what happened? Oh, so the number units are in pure number. Okay, that's the problem. So I go 88 to 108 because it's in megahertz, right? Okay, we are done with it. So this is the 66th channel, and this is the 50th channel. And this one, so it says some error is there. X must be positive. Oh, you know, you cannot go 0 because MATLAB doesn't accept the index of 0. Okay, now it's okay. So we have a spectrum here. Sorry about that. We have a spectrum at 88, right? But then you have enforced 88 to 108. So that's there. Now I can vary this to the other extreme end, which is going to be here, right? Now there is what you call a component here which can do the same stuff irrespective of your scaling on the x-axis. Let's see if that component is okay. Envelope FC change, right? And here I can say characterization to be characterization to be 98 as the center. So I'm fixing the center 98 megahertz. Okay, so now it's not doing anything different, right? Because you have fixed your uh, x-axis. Okay, you can manually do it or you can do it through FC change. It doesn't matter. So the center would remain. Okay, doesn't matter. So in that case, what you have to do is you have to cover the entire range, right? So I'll go to this analysis and I'll put the entire band 20 megahertz. Okay, now what's the problem? The simulation sample rate 20 megahertz is too small. Loss of information may occur. Okay, anyways, let's accept that. Okay, so now if I move the channel, so now you can see the channel moving, right? So the center of the axis is backed at 98, right? So basically, you can use this modulator not just as an IQ modulator or M-array PSK modulator, or you can also use this as a frequency, phase, or amplitude modulation. So, you can use this modulator as anything you like. Okay, so this is a very simple exercise where you can do some form of analog modulation. Okay, so this was a very short exercise on the modulator being used for analog modulation. I don't see a lot of significance of this unless some students want to study this, and just for being comprehensive, I have just left it there, right? You can also look at one more thing is that the complex signal which is coming up. So let's add another graph, and let's look at output signal. Let's say I want to look at magnitude, or rather, yeah. Okay, the magnitude everywhere is going to be 1, right? Just right. So the magnitude everywhere is 1, and let's see, add output signal time domain. Magnitude is always 1. Real part. Okay, why don't I see the real part? Uh, Okay, so that's the real part, and then you can look at the imaginary part. Okay, so magnitude always remains 1. It's constant and envelope. All the information is in the phase, right? So that's all I'm trying to say here. All the information is in phase, no information in the magnitude. Okay, okay. So I'm gonna stop here. Nothing much special about this. In the next session, I'll start with a more serious effort, like looking at the LTE system. So wait for that session. Thanks a lot. Thank you very much.